For problem number 5, we're given the function f and the function g. We are going to divide them and then to see where is h of x greater than 0. That basically means where is the function positive or above the x-axis. Now to do this, it's going to be a little bit of work, especially since we can't use a calculator. So let's get started. I'm going to write down h, and so h is going to be these two quantities divided, specifically with f on top and g on the bottom. So x cubed plus 2x squared minus 8x divided by x squared minus 7x plus 10. So let's go ahead here, and if you haven't done so, go ahead and let's factor this. I can factor out an x. I'll be left with x squared plus 2x minus 8 over x squared minus 7x plus 10. And then we're asking myself what two quantities multiply to equal negative 8 and combine to equal positive 2. That's going to be x plus 4 and x minus 2, and in the bottom will be x minus 5 and x minus 2. Negative 5 and negative 2 multiply to give you 10 and combine to give you a negative 7. Okay, so what do we know about this graph? Let's go over this. Well, we can see here that we can identify that there is a hole in the graph at x equals 2. Now, when there's a hole in the graph, that means that the output is undefined. So it does not exist, we could say. So when h is equal to 2, it is undefined or does not exist. Okay, let's go to the next part. What else do we know? We know that we have a vertical asymptote. I'm going to abbreviate. We have a vertical asymptote at x equals 5, and the same thing is true. So here we can say that at h of 5, it is undefined because no value exists or corresponds when h equals 5 due to the vertical asymptote. Now we can also see that if I take two quantities on the top we can always see where the x-intercepts occur. So I'm going to take x equals 0 and x plus 4 equals 0. Well, here it's already defined for us, so we know h of 0 is equal to 0, and we also know that h of negative 4 is equal to 0. Okay, so I'm going to now focus in on these values of 0 and negative 4 and 5 and 2. Remember, it does not exist, whoops, forgot the end there, does not exist an output value when x equals 5 for this function, when x equals 2. Okay, here we go. Let's take those values. So here is 0 with 1, 2, 3, 4, 5. Here is negative 4 and 0. So this would be the x-intercept, and this is the x-intercept. We also know at positive 2, no output value exists, so it does not exist. And we know at 5, we do not have an existing output value. So let's make little lines here. Think of these as temporary walls. I'm going to go back up to this abbreviated function. I'm going to write that down at this time. Let me grab another piece of paper to be able to demonstrate algebraically what I'm doing. So we know h of x is equal to x times x plus 4 over x minus 5. Now the entire goal of this problem is to find out when is h of x greater than 0. So when do I have positive outcomes? That's my goal. So let's just choose one value to the left of negative 4. For instance, let's choose negative 5. And now I'm going to plug this in. So I would have a negative value, and negative 5 plus 4 is a negative 1, so another negative value, and negative 5, excuse me, and negative 5 and negative 5 minus 5 would be a negative 10. So I have a negative times a negative, okay, that's a positive, and a negative on the bottom. Well, a positive value divided by a negative value equals a negative. So over here, I'm going to write negative. Remember, my goal is to decipher which intervals produce a positive value or greater than 0. This is negative. I'm going to choose one value in here. Let's make it as simple as possible, so it's between 0 and negative 4. It can't be those endpoints. Let's try negative 1. So this would be a negative. Now negative 1 plus 4 would be a positive 3. Negative 1 minus 6 would be a negative 6. Negative times positive is a negative. A negative divided by negative is a positive. That's perfect. So this is positive. I know that one range will be negative 4 up to negative 1. Okay, let's look at the next one. Let me fold this down to provide myself a little more space. I'm going to choose something between 0 and 2, 1 being the obvious easy choice. So h of 1, remember this was the formula, x times x plus 4 over x minus 5. Okay, plugging in 1, I have a positive. 1 plus 4 is 5, that's positive. 1 minus 5 is negative 4, that's a negative. Positive times positive is positive. Positive divided by negative is negative. So this produces a negative value. I'm only looking for positives. So between 2 and 5, I don't know, let's choose 3 for instance. Do a 3. H of 3. Okay, so again, this is the formula that I'm working with right over here. So 3 is positive. 3 plus 4 is positive. 3 minus 5 is negative. Positive times positive is positive. Divided by negative produces a negative. Let's choose a number over here. Let's choose 6. H of 6. So we have a positive right here. 6 plus 4 is positive 10. 6 minus 5 is a positive 1. A positive divided by a positive is in fact a positive. So I want to choose an answer that says I can find positives on the function h of x between negative 4 to negative 4 to 0, sorry, mistake there, to 0, and 5 beyond. Let's look at our choices. And it looks like our choice can be found in option B.